Hello students, welcome to Real Academy. My name is Rajendra Choudhary and I am a maths faculty over here. Today we will be discussing a very important aspect of coordinate geometry, that is distance formula. Okay, coordinate geometry is a topic which you have been studying since your earlier standards, correct? So this is something that is under that topic only. But before we go to details of distance formula, let us try to understand a simple example. Okay? So imagine there is a point A where you live, this is your home, correct? And then 15 meters to the north, okay, 15 meters to the north and 30 meters to the east, okay, 15 meters to the north and 30 meters to the east, your friend lives. This is the house of your friend, okay. 15 meters north, 30 meters east. Okay, so this is the north direction, this is the south direction, this is the east direction, and this is the west direction. Now, suppose somebody asks you to find the distance between your house and your friend's house, which is at point B. How will you find the distance? Okay, whatever dimensions I gave you, they are not the accurate distances. Distance kaise pata chalega? Which will be the direct line connecting A and B. Now if you look at this figure, okay, it forms a right angled triangle. So in a right angled triangle, if you want to calculate the distance, that is the hypotenuse, how do you do it? We use simply the Pythagoras theorem to calculate the distance between AB, correct? So if somebody asks you what is the distance between your house and your friend's house, what you will do is AB, the distance AB, its square will be equal to, what is Pythagoras theorem? Hypotenuse square is equal to sum of squares of the other two sides, which is AE square, that is 30 square plus 15 square. Okay, so the exact distance between your house and your friend's house will be square root of 30 square plus 15 square. Now the reason I gave you this example is distance formula can be derived using this example also. It's very simple. So by now you must have guessed the name is distance formula. Okay, so the formula is used to find out the distance between any 2 points on the coordinate axis. Okay, so in this diagram you can see that there is a x-axis, there is a y-axis, and they intersect at origin, that is the 0 point, correct? And you know from your previous standards that the right side of the origin is the positive direction for x. So 1, 2, 3, 4, 5, 6 at uniform distances, we mark the points in this way. On the left side of origin, -1, -2, -3 and so on. And for the y-axis, in the upwards direction, it is +1, +2, +3, 4, 5, 6 and so on. And what is the negative side for y-axis, which is below the origin? That is -1, -2, -3, -4, -5, -6 and so on. Okay, you also know how to plot points on the coordinate axis, correct? So if you want to plot a point on the coordinate axis, you must know its coordinates. For example, a point 3, 4. Where will this point lie on this coordinate axis, correct? So 3 on x-axis, this is the abscissa. Abscissa means the x coordinate, correct? That is the first coordinate that we see. 3 on the x-axis, 4 on the y-axis. So the point is the intersection of the lines passing through 3 and 4 and parallel to the respective axis, correct? This point is 3, 4. Now these are all the very basics of coordinate geometry which you have learned in your earlier standards. Now what we are going to study is how to find out distance between any two given points. For example, this is 3, 4 and I give you another point, let us say -2, 6. So the point will be here, okay, -2, 6, the point will be here somewhere. So what is the distance between these 2 points? Directly by looking you cannot calculate, correct? So if you want to calculate the distance accurately, without drawing the graph, okay, there should be a formula for that. Okay, otherwise what I'll have to do, I'll have to draw the graph, plot the points, measure the distance using a scale. If you want to avoid that, there is a direct formula by which you can calculate the distance between any 2 points on the coordinate axis. Now how to calculate that, let us see. On the same coordinate axis, okay, let us assume 2 points. This is the origin. Let us assume 2 points. First one having coordinates x1, y1. Okay, there is a point with coordinates x1, y1, and let us assume a second point with coordinates x2, y2. Okay, for our formula purposes, we are not giving them accurate values. These are just variables. x1, y1 can be any point, x2, y2 can be any other point, second point. Okay, so we have to calculate the distance between these 2 points. Now the distance between these 2 points will be the line joining these 2 points, correct? x1, y1 and x2, y2. Agar मैं join करता हूँ, so this is the direct distance between them. Let this be point A, x1, y1. Let this be point B, x2, y2. Now, if you know the concepts of coordinate geometry, what is the x coordinate of this point? The x coordinate of this point is x1. So this here is x1, correct? Similarly, what is the y coordinate of this point? It is y1. So its ordinate is y1, which will be here, correct? So this is x1, this is y1. Similarly, for the second point, x2 will be the x coordinate. So when you project it here on the x axis, this is x2, okay, and for y2 it will be projected here, which is the point y2. Now why we are doing this? So if I draw a straight line like this, okay, and once again a straight line like this, a right angled triangle is formed. Okay, in this right angled triangle, if we know these two distances, this distance and this distance, we can find out the third distance, which is the hypotenuse, correct? The question is, what are these two distances? So just look at the figure carefully. From 0 to x1, correct? You know on the number line how much is the distance between 0 and any other number? It's the number itself, correct? So 0 to x1, the distance is x1 units, correct? Similarly, 0 to x2, the distance is x2 units. So what is this distance? All you have to do is, from x2 units, you have to subtract x1 units. So from total this much distance, if I subtract this much distance, this is the remaining distance, correct? So this distance is nothing but x2 minus x1. Okay, this distance is what? x2 minus x1. Similarly for y, this distance is y1 units and this distance is y2 units. Okay, this is y2 units, this is y1 units. So what will be this distance? Just like we discussed in this case, x2 minus x1, this distance will be y2 minus y1. Okay, now we have both the distances, we have to find the third distance, so we can easily derive our distance formula. Okay, according to Pythagoras theorem, what will be the formula here? By Pythagoras theorem, okay, you can see in this diagram, this is point A, this is point B, and if I name this point C, by Pythagoras theorem we can say that AB square will be equal to AC square plus BC square, correct? We have to find the value of AB, which is the distance between those 2 points, right? So this is equal to, what is AC? AC is x2 minus x1, so x2 minus x1 the whole square, plus what is BC? BC is y2 minus y1, so y2 minus y1 the whole square. Okay, now this is the value of AB squared. We only need the value of AB, so therefore distance between AB is equal to, if we take square root on both sides, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, now this, my friends, is the distance formula. Now let us try to understand how this formula works. Okay, for example, if we take 2 points, let me go to the next page. We have to find, suppose, the distance between the points minus 1 comma 3 point A, okay, and point B, that is 2 comma minus 1. Okay, so if you want to find the distance between these 2 points, you can find it using the distance formula. You can assume anything. You can assume this to be x1 y1 and this to be x2 y2, or if you take them the other way around, even that is okay. If you assume this as x2 y2 and this as x1 y1, it's still okay. The answer will not change. So don't get confused. You can assume them in any particular order. This can be x1 y1 or this can be x1 y1. But you have to make sure that if you consider minus 1 as x1, your value of y1 will be 3 only. You can't take y1 minus 1. Okay? Cross nahi chalega. If this is x1 y1, you have to consider them together only. Okay? So if you solve it using the distance formula, the distance between points A and B by the formula x2 minus x1 the whole square plus y2 minus y1 the whole square can be given by, just substitute the values. As I told you, x2 can be any one of these two. If I consider this as x2, so 2, now my x1 should be this, minus, again minus 1. Don't forget, okay, this minus sign is a different minus sign and this is from the formula. So 2 minus minus 1 the whole square. It should be a square bracket plus, in this case, y2 minus y1. So I have considered this as x2. So y2 should be minus 1 only, correct? So minus 1 minus 3 minus 1 minus 3 the whole square. What is the value of this? Square root of 2 minus minus 1 will become 2 plus 1. Okay, so 3 square plus minus 1 minus 3 will be minus 4. So minus 4 square. Okay, the value of this will be 9 plus 16. Okay, which is square root of 25. Now you all know square root of 25 is 5 units. So the distance between points A, B can be given as 5 units. Okay, this is how the formula works. Now unit, it can be anything. It depends on what you are considering. Okay, on the graph paper. So it can be in centimeter, it can be in meter, anything. Okay, so this is the distance between points A and B. This is how you calculate it. Now, like I told you, if you take them in the reverse order, still the distance won't change because of this square. Okay, so the square of the number, even if it's negative, is positive. As you can see, minus 4 square is 16. But if you take them in the reverse order, okay, minus 1 minus 3, still it is minus 4 square. So if you take them in the reverse order, correct, in that case it will become 3 minus minus 1, correct. 3 minus minus 1 is plus 4. Plus 4 square is also 16. That is why the value doesn't change even if you take them in the reverse order. So this is how the distance formula works. Now let us see one of the applications of distance formula. ये use कहाँ पे होता है? One application is to find the distance. Obviously, that's its purpose, right? There is one more application. Distance formula can be used to check the collinearity of points. What is the meaning of collinearity? Okay, for example, किसी ने बोला कि ये 3 points है 1,3, 1,2, 1,4 and check करो कि on the graph paper when you plot these points whether they will lie in the same straight line or not. मतलब तीनों points same straight line पे आते हैं कि नहीं. Okay, तो ये बिना plot किए कैसे find कर सकते हैं? Using distance formula. So distance formula can also be used to check the collinearity of points on a graph paper. Now let us take an example of this. ठीक है, suppose I have 3 points 0,3 point A, 0,3 is point A, then we have point B 3 comma minus 3 and point C 4 comma minus 5, and I have to check whether these 3 points will lie on the same straight line or not. Okay, using the distance formula. How can we do that? So how this works is like this. Suppose this is the straight line on which point A, B and C will lie if we check it to be correct. ठीक है? So अगर ये तीनों same straight line पे होंगे, that means the distance between AB, when we add it to the distance between BC, it should be equal to the distance between AC. Okay, what I'm saying, I'll repeat once again. If they lie on the same straight line, the distance between AB, if we add it to the distance between BC, it should be equal to the distance between AC. Correct? That is the meaning of collinear. If we add the distances between AB to the distance between BC, okay, it should be equal to the distance between AC. So when we solve this, or when we check the collinearity of these 3 points, what we are supposed to do? First, find out the distance between AB. Second, find out the distance between AC. Third, find out the distance between AC. If it happens in such a way that this distance plus this distance is equal to this distance, that means they are collinear. Otherwise, they are not collinear. Acha, it is not necessary कि A, B and C only are collinear. हाँ? The order can be anything. It can be A, C, B also. इसका मीनिंग क्या हुआ कि distance between AC plus distance between CB is equal to distance between AB. Okay, it can be in any particular order. Collinear का मीनिंग होता है सिर्फ कोई भी दो distances को add करके जो third distance है, which is the largest distance, it should be equal to that. Correct? So let us check whether these points are collinear or not. Okay, first find out distance between AB. Distance between AB. We all know the formula. By now you should be by hearting it. x2 minus x1 the whole square, y2 minus y1 the whole square. Correct? This is the formula. So substitute the values of x2, x1, y2 and y1. For these 2 points, if I consider this x1, y1, this x2, y2, okay. So square root of 3 minus 0, x2 minus x1, the whole square, plus minus 3 minus 3, minus 3 minus 3 the whole square. Okay, so this is equal to square root of 9 plus minus 3 is minus 6. So 9 plus 36, positive 36, इसका square root आएगा, which is square root of 45. Okay, now square root of 45, if you see, it can be simplified as 9 into 5. 45 is what? 9 into 5, right? And square root of 9, so it can be taken outside as 3 under root 5. 9 root is 3. So root 45 can be written as 3 root 5 units. So this is 3 root 5 units. Okay, let us go to the next distance now, which is distance BC. हम लोगों ने distance AB देखा. Now we will see distance BC. So let us check distance BC. It will be square root of, okay, there's no need to write the formula again and again. We will directly solve it. This is x2, this is x1 suppose. So 4 minus 3 the whole square plus y2 minus y1. So minus 5 minus minus 3. Two minus signs will be there. Minus 5 minus again minus 3. Okay, so I'll use a square bracket, the whole square. So this is equal to square root of, this is 1 square and plus minus 5, minus minus will become plus 3. So minus 5 plus 3 will be equal to minus 2 the whole square. Okay, so here what you are getting, 1 plus minus 2 square is positive 4. So root 5 units is the distance here. This is distance between B and C. Finally, let us check the distance between A and C. Okay, distance between A and C. So finally, distance AC. Again, use the same formula. This is x2 y2, this is x1 y1. So 4 minus 0 the whole square plus minus 5 minus 3 the whole square. Minus 5 minus 3 the whole square. So what is the distance here? 4 minus 0 is 4. 4 square is 16. Correct? Minus 5 minus 3 is minus 8. Minus 8 square will be positive 64. So plus positive 64. When you add these two, you will get square root of 80. Square root of 80. 80 is what? 16 5s are 80 hota hai. So I'll write 80 as 16 into 5, which means square root of 16 can be taken outside. Correct? Square root of 16 is 4. So this can be simplified as 4 root 5 units. So we got all three distances, and if you observe it, 3 root 5 plus 1 root 5 will be 4 root 5. Correct? Which means when we are adding distance AB to distance BC, it is equal to the distance between AC. That means these 3 points A, B and C, they are collinear. Okay, so that is how we can prove collinearity of points using the distance formula. If the distance is not equal, okay, so out of the 3 distances, if the biggest distance is not equal to the addition of the other 2 distances, then the points are not collinear. Okay, so that's why we can use this to find the collinearity of any given points. So this is what distance formula is all about. There are many more applications. We will discuss them in the lectures. Thank you everyone.